There's a number of choices that need to be made when designing these systems, and our primary focus will be on domestic green electrolysis projects. As the learnings from these are far greater, these projects are moving through execution. Hopefully in 5 years we'll be able to come back and talk about the export projects that are ramping up. I guess the first key decision in designing any systems, and potentially the hardest, I think it's definitely been the hardest that most clients have been grappling with, is the offtake. This requires understanding the customer and their pressure, quality, flow rate, fluid type requirements. And this is really challenging with markets and technology still emerging. The customer has real uncertainty around their consumption, be it export, whichever market you're going to sell into, or mobility, selling to a bus fleet or a truck operator. There's just so much uncertainty around the technology. It's very hard to lock in the spaces. If you look at it over a monthly basis, you can see a flat, the top line is a constant demand 7 days a week with no seasonal variation. But when you start to dive deeper into these fleets and how they operate, the times that they operate, and apply some uncertainty around that, you can see the actual monthly demand could be much lower. So you've got to account for this both in your system sizing and your designing and your business case when you're putting it together. I guess the key takeaway is that you really need to understand your customer, be it mobility or export, their operation, their application, and really dive into that part of the study of the project before you go too much further. I think the biggest challenge around storage is still the intermittency of the upstream grid supply, power supply. And it becomes particularly challenging when you want a firm supply downstream, such as a continuous process like an ammonia plant or a methanol plant, where there's limited flexibility and higher reliability required. Firming up upstreams has additional benefits, increasing the operating life of the electrolyser stacks, smaller capacity, but the costs of managing an upstream, whether it's buying additional power from the grid or through batteries, is still quite high. So it's a techno-economic piece around what the best solution is at the moment. And as technology evolves and as markets evolve, the solution may change. Regulatory and safety requirements become a real limiting factor in some locations, particularly when you're talking about tons of hydrogen storage on site. Electrolysers, obviously one of the key enablers to this whole green hydrogen revolution. To assess these, you need to take both a qualitative and quantitative approach. But the first step is to develop a set of performance requirements for your particular application. This will be heavily based upon the supply and demand profiles. Sensitivity analysis is really critical in this part, particularly because you might see particular inputs having opportunity to move. One of those is CapEx, with government offering good financial incentives on CapEx. So maybe something that's a little bit higher up front but has lower OpEx costs actually looks better in the future. Looking at safety and safety requirements, some of the challenges around equipment vendors still trying to navigate compliance pathways. There's still plenty of uncertainty around separation distances and exclusion zones and how that impacts site selection and other aspects of the projects. Where standards don't exist, generally safety risks can be quantified using first principles and specialised risk models. So legislations and standards do need to be considered early in any hydrogen system design to make sure that the location that you've selected is appropriate, the equipment that you've selected is suitable, and there's no safety risk or additional risks that can't be mitigated throughout the project. And finally, site selection. Typically, this is a number one priority, but we've found with a lot of these projects, it's actually a very fluid aspect. Usually this is driven by market. So we've seen projects where the sites change quite significantly. So there's a lot of work in designing confirming that demand basis, understanding your storage requirements, and then you can start really looking at where's the site to position in relation to your grid connection or your behind the meter solar or your energy supplier. I think when you look at the site selection, the site needs to be appropriately sized for any risk, for any safety exclusion zones. Needs to be close to the market, and you really need to consider the network connection costs if you're connecting to a grid. That whole power supply system can become quite expensive, and in this scenario, it ended up being 25% of the total cost. if you look at the actual electrical equipment augmentation costs, it's as much as the electrolyzer in this scenario. So it shows you how critical that aspect of the project is. So some of the opportunities that we've seen to arise to solve are local procurement. I think there's a real opportunity to start sourcing equipment locally. That might be the subsystems, the water treatment, balance of plant, to remove any compliance risks and procurement risks, or to remove a lot of them. There's definitely an opportunity in that power systems optimization between the grid connection or the solar and wind to the DC of the stack, and really looking at ways to reduce that by removing equipment and improving efficiencies. I think you'll see a lot of focus on that in the next few years. Understanding how we repurpose existing infrastructure, particularly pipelines, still a big uncertainty. There's a big question around embrittlement and how does that factor into old pipelines, but there's a lot of work in that space in the research, and in the next few years, hopefully we'll have a better understanding of the feasibility of that. Storage, I think there's a great opportunity for both small and large scale storage to look at additional technologies. Hydride could be interesting for smaller plants, and geological stuff for the large scale stuff. I think storage is the one challenge that I see at the moment, and I hope we can work on that in the next few years. And availability of vehicles and off-takers to drive domestic markets are a bit of a challenge, and hopefully, in the next couple of years, the likes of Hyzon and all these guys that are building vehicles can deliver them, and then I think we'll really see domestic mobility markets explode. It's mostly pressure or dependent on cycling. A large number of pipelines will be okay as long as the pressure doesn't cycle too significantly. It also depends on the existing condition of the pipeline. Second, the design factor pressure combo, so a high design factor and high pressure, the loss of toughness starts becoming an issue. So in those scenarios, the pipelines might require derating. There's obviously plenty of research in this space across Australia and the world. FFCRC are starting test programs where they're actually testing steels and to fully understand the impact, and the results of that testing and the research that's going on will feed into standards and codes of practices, which are just starting to be developed at the moment. That Jemena project, that pipeline was designed to ASME B3112, so there's a pathway for design of new pipelines. It's just that repurposing that's got to be updated. And it's key risk being able to have the people that know what they're doing to support these projects. And you look at a large-scale plant that might take hundreds and hundreds of engineers to design, and then through the operation phase, there's a lot of people going to be required to make this work. Final thoughts. So I think there's been a lot of work in the last 5 years in Australia with projects moving through execution, just pilot projects at this stage. A lot of learnings can be developed from these projects. There's a number of risks that have been carefully managed to ensure the success of these projects, and they need to continue to be as the industry evolves.